All right, Sharks, this is Mr. O back with Flip Notes. It's been a while since we had a set of these. We are getting off of our plant and plant response unit, and now we're moving into our next big unit, which is matter. Matter and waves are the two biggest units. Matter is 6P21. It's actually 6P21 through 3. In your composition notebooks, this is page 13, which is Matter 1 Notes. So first of all, the big idea of this whole unit is you have to understand the structure, classifications, and the basic physical properties of matter. A lot of this stuff will not seem too new to you, but maybe together it is something pretty new. We're going to start with some key vocab early. So we're going to start with the first one is going to be matter. Obviously, if the units matter, we're going to start with the word matter. And then the most basic definition that holds true for this would be anything that has mass and volume. So when you can answer yes to both of the things, that it has mass and it takes up space, then that is matter. If it doesn't, you can't answer yes to both of those, it's not classified as matter. Now, matter, if you haven't realized already, is a very big topic. All matter in the world starts with one thing, and it's an atom. Atoms are the small particles that compose or make up, the word compose means make up, all matter. So anything that is matter, so if it has mass and volume, it is made up of atoms. Now atoms are super small. There's no way I can tell you how small they are. There's thousands and thousands and thousands in the tiniest spot. It's almost hard to understand, but just understand that the atoms of anything start it. And then you've heard about the periodic table elements. It looks like this. That's a fancier one, but seeing the periodic table elements is in your agenda. And elements are made of atoms, and then these elements make up matter. So if you started to see there's a connection with these words, that atoms make elements, and then elements will make the next vocab word, which is molecule. And I'm going to show you a picture, a couple different molecules. That is the not real picture of H2O. And that's really what H2O looks like when it's combined in water form, if you're able to get a super high powered microscope to look at one. And a molecule, by definition, is formed when two or more elements combine. Now, the elements can be the same, they could be different, but there has to be two or more. That makes a molecule. So if you haven't noticed, atoms make up elements, elements combine to make up molecules. So you see how the words are starting to connect together. Now, if I'm going to talk about one particular thing, like a particle, so I have a picture of the different states of matter here, solid, liquid, and gas, which is what we'll get into next in this unit, but not yet. Particle, by definition, are smaller pieces of anything. If you see the word particle, it has the word part in it because it's a part of something. For example, if you're talking about your outfit, a part of your outfit might be your jeans. So if you're talking about an atom, a part of that might be a proton or a neutron or an electron or something along those lines. The next section for matter is this man named John Dalton's atomic theory. That's a picture of John Dalton there. You don't need to know what he looks like. But John Dalton came up with things that classifies things about atoms that hold true to this day. Number one, atoms cannot be broken into smaller pieces. Meaning you can look at protons, neutrons, and electrons, but what this statement means is that the atoms are the smallest building blocks. There's nothing smaller than an atom. So if you have an element, there is something smaller than an element. You can have an atom. But an atom, there is no going back from that. So John Dalton's first thing is atoms cannot be broken into smaller pieces. His second thing in his theory is in any element, all those atoms are exactly alike. Meaning, if you look at hydrogen, which is on the periodic table of elements, every hydrogen element in the entire world, all those atoms are exactly the same. Number three, atoms of two or more elements can combine to form compounds or molecules. We just saw that with the definition. This came from his theory, still holds true today, meaning atoms can combine to form up molecules and compounds that we make up things that we have today. And the fourth thing is atoms of each element have a unique mass. We'll look into the periodic table a little bit, and you'll realize you'll look at a lot more in 8th grade. But when you'll look at everything on the periodic table has a different atomic weight and mass, and John Dalton had these four things in his things. You will be required to know these 4 steps of his theory, so keep that in mind. So John Dalton's theory, and these are the 4 things that you will be required to know and be able to use in real-world situations later on in this unit. Some key points before we finish up. These are just statements that are true that you have to get comfortable with knowing these things. All matter is made up of atoms. So if it's matter, it's made up of atoms. Okay? Different elements contain different atoms, meaning if it's a hydrogen element, that has different atoms than a helium element would. And finally, everything is matter except energy. After we get through this unit, which is like 7 to 9 weeks, depending on how long it takes, we will get into waves. And waves deal with energy. Because combined, matter makes up everything, and then the only thing it doesn't make up is energy, which we will get into our next unit. So those statements you will be required to know as well. I hope this wasn't too long, and we will look forward to getting into this new unit. It's a pretty cool unit. I'm sure you'll enjoy it. See you in class tomorrow.